Hi, my name is Scarlett. In this video, I will walk you through the steps that I took to improve the performance of my classifiers and assess its fit for a machine learning task, where the goal was to predict whether a person will have a stroke or not. I will be covering everything from feature engineering to model selection and tuning, and how I used various techniques to improve both the performance and the fit of my model. So let's start with the steps that I took to improve the performance of the classifier. So first of all, I performed feature engineering to create interactive features that can capture relationships between the variables. For example, I combined age and BMI um, to to create a new feature, which is BMI underscore H. And I also combined hypertension and heart disease into another feature. These new features help the model capture nonlinear relationships between the variables, which may be useful in predicting stroke risk more accurately. Next, I addressed the issue of class imbalance by using SMOT, which is synthetic minority oversampling technique. This generates synthetic data points for the minority class. This helped balance the dataset and improve the model's ability to predict the less frequent class, which is stroke occurrence, without overfitting to the majority class. Next I after performing feature engineering and handling class imbalance, I used PyCaret's built-in cross-validation to assess and improve the fit of my model. Cross-validation allows me to evaluate the model performance across multiple data splits, ensuring that the model generalizes well to unseen data and doesn't overfit the training data. Next, to further improve the model, I utilize PyCaret's automatic hyperparameter tuning capabilities, such as this process optimized the parameters of the models, such as the number of trees in a random forest or the learning rate in gradient boosting methods, which is significantly improve the F1 score. Um, and also, like GBM was one of the best performing algorithms that I found. Um, yeah, by um, I also used a tuning function to improve the like GBM model's ability to handle the dataset's characteristics, leading to a higher F1 score. And the last model that I tried was model stacking. Um, I decided to stack light GBM and extra forest model, extra trees model together. And stacking allows me to combine the predictions of multiple models, making the overall system more robust and less prone to overfitting or underfitting. Um, Now let me explain how I assessed and improved the fit of my classifier. So after stacking the models, I implemented cross-validation again on the stacked model. This helps in assessing whether the stacked model performs well across different data splits and ensures that it generalizes well without overfitting. Cross-validation also provides an additional layer of confidence in the results as it shows how the model performs across various subsets of the data. Additionally, as you can see in my notebook, I have plotted learning curves for the models to visualize how the performance changed as the model trained on more data. The learning curve helps identify if the model is underfitting or overfitting. This way, I could ensure that my models were neither underfitting nor overfitting. Finally, I also have confusion matrix for the models to assess their ability to correctly predict both classes, stroke and no stroke. The confusion matrix helps me understand how many false positives and false negatives the model is generating. With this information, I could refine the models to reduce misclassifications. In summary, I improved the performance of my classifier by implementing feature engineering, handling class imbalance with SMOT, tuning models, and stacking multiple strong models. To assess and improve the fit of my classifier, I used cross-validation, learning curves, and confusion matrices. And all these efforts, I improved the F1 score of my classifier, and the highest F1 score that I received was from the light GBM model. Thank you for watching, and I hope you find this process insightful.